Okay, today we are going to start chapter 9, and we're going to solve quadratic equations. And so to start, this is going to be very similar to what we did at the end of chapter 8. So 9.1 says use the zero product property to solve the quadratic equations below. And so here we go. If we're going to use the zero product property, that means we need to set it equal to 0. So we're going to subtract 9 from both sides, and then that tells us what we need to factor. So when you set it up, you have your 3x squared, your negative 15. When you multiply those, it's a negative 45x squared. And then you need it to add up to be 4x. 9x and negative 5x will make that work. So you can plug that in to your other two rectangles, or other two squares. And then you can break this apart. So you have 3x squared. So you bring down your 3x because it has to go down, because 3 will go into 9, but it wouldn't go into negative 5. So this one's 3x and this is x. 3x times what gives you 9x? 3. And then x times negative 5 gives you negative 5x. Then you can double check, make sure you get negative 15. Bada bing, bada boom, you're good. So you write it out, 3x minus 5, x plus 3 equals 0. Then you solve it. Set this one equal to 0, so you'd add 5 to both sides and divide by 3. This one, subtract 3 from both sides, and that would give you your two answers. On B, this one is already factored, and so if you divide both sides by 3 to get rid of your coefficient there, it still equals 0. So then here you've got x minus 5 equals to 0, so you solve and get 5. This one you would have 2x plus 3 equals 0, so you'd subtract 3 from both sides, and then divide by 2. And then for C, there's only two numbers here to factor, and it's not a difference of squares, so just take out what they have in common. So they have an x in common, so when you factor out an x, you'd be left with x plus 6. X equals 0, well, that one's solved for you, and then x plus 6 equals 0 has to be negative 6. Now it says graph 3x squared plus 4x minus 6. Like graph that on your calculator, you get the same thing. Where in the table on your graphing calculator would you look to verify your solutions to the part A of this? You're going to look at the x-intercepts, or where y equals 0. Use Desmos. So you can do that. You'll see that they're the same. Now we're going to talk more about completing the square. So it says Janelle's team is trying to solve this. She suggests using the zero product property. Kira says that quadratic's not factorable, so it doesn't have a solution. Is Kira correct, and how do you know? So if you try to factor this, you would never find something that multiplies to be negative 1 that adds up to be a negative 6. And so it is, she's right, it's not factorable. However, it could still have a solution. It just means it's not an integer solution. And so let's see how to do this. So here where it says let's use the graphing calculator, so just type this into Desmos, and then you can estimate that the two x-intercepts are negative 0.2 and 6.2-ish. But you could also solve it like we did when we were completing the square a couple weeks ago, and you could follow these steps. Now you can add negative 8 tiles to each side. I'm not so sure. That'd give us negative 9 in the corner. Is that right? And so like you can kind of read through that. I like to just go back to, since we've already talked about completing the square, just doing it like we did. So bring down your x squared minus 6x, and then put your plus 1 over here, and then complete the square. So think about 6, you need to divide that by 2, that's 3, squared is 9. So you'd add 9 to both sides. Then you would have x minus 3 squared equals 10. Square root of both sides. Then you get x minus 3 equals plus or minus 3.16. So when you add 3, you would get 6.16. If you add 3 to the negative 3.16, then you would get 0.16. And so to make sense of the x-intercepts in part D, you probably wrote your solution as a decimal. Square roots that are not perfect squares are irrational numbers. They are numbers that cannot be written as a fraction of integers. Irrational numbers cannot be written exactly as a decimal or rounding them. The decimal continues infinitely and never goes into a repeating pattern. When you write a square root as a decimal, you have to round, so it's called approximate decimal form. When you use the square root symbol, you are using exact form or radical form. So here's this equation. It said build it with algebra tiles. I'm just gonna solve it the way we've been solving, completing the square. And so x squared plus 4x plus 4 equals, So we have x squared plus 4x minus 5 equals negative 2. So the first thing is you're going to want to add 5 to both sides, and that's where the 3 comes from. Then think about what you would have to do to complete the square. Divide this by 2, and then square it. So it gives you 2. So then you have the square, or x plus 2 squared equals, don't forget to add it to both sides, so it equals 7. Square root both sides, you get x plus 2 equals plus or minus 2.65. Subtract 2 from both sides. When it's a negative 2.65, when you subtract 2, you get negative 4.65. When you subtract 2 from the positive, you get 0.65. Here's what it looks like in exact form or in radical form. Just keep it at plus or minus square root of 7. Then when you subtract 2 from both sides, that's what your answer looks like. That's a lot easier than having to deal with the calculator, that's for sure. Okay, 2 more. I think I'm going to do a second video for those.